Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in today's video we are going to learn about the basics of motion under gravity. First we will learn this in the absence of air, because in the absence of air calculations will be simple. Then after that we will learn some little bit basics more in presence of air resistance. Okay students, so let's start the video and let's learn the basics of motion under gravity. It is very important to solve the questions. Okay students, so let's start the video. So here you can see the topic is motion under gravity. So let's see, it is a kind of uniformly accelerated motion. Why? Because the value of acceleration due to gravity is constant, and here we will use A equal to plus minus g meter per second square, depending upon the sign convention, sometimes plus, sometimes minus. And you know very well the value of g, how much? 9.8 meter per second square on the surface of the earth, okay, or near to the surface of the earth, up to few kilometers, okay, because in gravitation chapter you know very well the gravity value will change when you go too much height, okay, but near to the surface of earth we will consider the gravity is constant, and this kind of motion under gravity will be considered as a uniformly accelerated motion. That means equations of motion will be valid, okay. So here remember that here 9.8 meter per second square, or sometimes we can use 10 meter per second square, not a problem. Now see here, normally we will neglect air resistance, as I have told you, to not make the calculations complex, okay. So first we will keep the things easy, that's why we will neglect the air resistance, okay. So can you see here the basics are here. Now after that we are going to learn the sign convention, okay, because a sign convention is very important. So see here, here I have taken here, no? This is the ground, like this here. Whenever we are drawing this kind of thing, no? This crossed lines, no? So this represents here the ground, okay. Now what is happening that here, from the ground I am throwing one object, okay, one object I am throwing with velocity u from point A, okay. So you know very well the gravity, acceleration due to gravity always acts towards the center of the earth, but here what will happen that here we are just showing with the flat ground, not exactly earth, so we'll just consider that here the gravity is acting in downward direction, okay. Or I can tell here, see, this is A equal to G, no? So this is the my gravity. Now after that you know very well velocity upward, gravity downward. That means here in this situation what will happen, that velocity and acceleration in a opposite direction, that means anyhow velocity will decrease. All these things we will see later, but now we are going to see here the sign convention. So see here, if in case I take sign convention upward positive, okay, upward I am going to take positive, if I am going to take upward positive and downward negative, okay. So in this situation, as velocity direction is upward, this velocity will be taken positive. Acceleration, you are knowing very well, the gravity is acting in downward direction, this will be taken as a negative, okay. And what about the air resistance? Remember that when the object will go upward, now air resistance will act downward, that means this is also minus, okay. Similarly, if I take the different sign convention, let's take, if I am taking here upward negative and downward positive, then what will happen that here, no? Upward negative I am taking, then what will happen, the velocity u will become negative, acceleration will become positive, and as I have told you, when the body will go upward, air resistance downward direction, and downward is the positive, that means air resistance is also positive. So you can see very well, acceleration can be negative also, acceleration can be positive also, depending upon the sign convention. That's why I have written A equal to plus minus G. Is it, students? So kindly see very well the sign convention, but remember that here in a basic way, nothing is mentioned means I will always use this first sign convention, okay. The first sign convention I will use it, okay, great. Now after that we'll go for the downward motion. Here also let's take here again we are what is happening, downward motion. Now let's take here from here. Now let's take here from here. I have taken here point C, okay, and from point C I have thrown one object in a downward direction with velocity u, okay. You know very well, anyhow the gravity will act in downward direction, A equal to G, is it? So you know very well the velocity is downward, acceleration also downward. So in downward motion what will happen, the velocity of the object will increase, okay. And anyhow this is the ground. So here what will happen that here, let's take for example, if I am taking upward positive and downward negative, then what will happen that here, as the downward direction is negative, this velocity will be negative, acceleration will be negative. Now as the object is going in downward direction, remember that here air resistance always opposes the motion. Okay, so see here, now air resistance will act in upward direction, object going downward, air resistance upward. Okay, so here air resistance will be what, positive, is it? And if I talk about here this side here, na, the body was going upward, so again it was opposing the motion, so air resistance was downward, is it? Remember that here. Now after that, if I take the reverse sign convention, see a reverse sign convention, if I take upward negative and downward positive, then what will happen that you can see velocity is a downward, acceleration also downward, so velocity will become positive, acceleration will become positive, and air resistance, yes, minus, na? So see here, but by default I will use this second sign convention by default. Why? Because all the velocities are downward, so if we are getting all this positive, why to put so many negatives and later you cancel out and all that. Okay, so remember that here wherever I put the star sign, by default I will take that sign convention only. Okay, great. Now here we are going to see in somewhat more detail case 1, upward motion in absence of air resistance, na, to keep the calculations simple. Okay, so here what is happening that here upward motion is this here. So first we need one ground. Diagram is very important, then only we can analyze the diagram and we can apply these equations of motion. Okay, so see here, let's take here, na, we are throwing object in upward direction, is it? Object is thrown in a upward direction, and let's take here this is point A. Okay, now after some point, let's take here, let's take at some point here, let's take this is the point B. Okay, and let's take here also the object will have some velocity. How much velocity is there? Let's take here I have taken the velocity point A, na, so VA I have taken here U. Okay, and here let's take here at point B, let's take here the velocity is V, and you will come to know that when the object is reaching at the highest point, that time what will happen, you know, the velocity of the object will be 0. Okay, so VAU, VBV, and VC how much here? 0. And if we talk about here the height. Okay, so height I am writing here, see here, let's take here this height, no? So this height, let's take here this height I have taken here H, no? This height I will take here how much here? This height I have taken here H, small h. Okay, again if I take here, no, maximum height, this is the maximum height. Kindly see the diagram is very important. Okay, and this maximum height is how much here? Capital H. All these things are ready now. So velocity is ready, height is ready. Now what about the time? So if I talk about the time, let's take the object is projected from ground at t equal to 0. Okay, and at point B, let's take time is t equal to t. Now, and at the highest point, the time taken to reach maximum height is called time of ascent. Okay, and at point C, let's take this time is t equal to ta. Okay, and to be more specific, if you want to write, you can write here this one here, time ta, time tb, and time tc. Is it? And this is which motion? This is the upward motion. And what I have told you by default, I will take upward positive and downward negative. So my sign convention tells that according to my sign convention, upward plus and downward minus. This sign convention I will use it here. Okay. Now students, after that if we talk about the gravity, gravity will act in which direction? Anyhow, downward direction. Okay. So if the gravity is acting in downward direction, now this is the gravity, downward direction, so what I will write here? A equal to plus g or minus g, depending upon the sign convention. Wherever A will come, it will become here minus g. A equal to minus g. Okay. Is it? Great. Now students, after that, if I will use here the equation of motion, first equation of motion, V equal to U plus AT. Why we are using equation of motion? Because G we are considering constant near the surface of the earth. Okay. So say here I am going to take here A is the initial point and B is the final point. So remember that here in all the calculations, see A initial and B final. So just tell me here V equal to U plus AT. Na? So final velocity how much here at point B? V. So V equal to initial velocity, you can see U plus acceleration A value minus G, because downward negative. So here I will write here minus G into T. Is it? That means what it will become here when we are going to apply V equal to U minus GT. Okay, remember that here v equal to u minus gt, is it? Similarly, if I use the second equation of motion, na? So see here, again I will use from A to B. Na? So see, what is S? S is the displacement. Displacement in which direction? See the arrow upward, and upward positive. So remember that here, plus h is equal to velocity also positive, time taken 0 to t, time taken t, okay, plus half a value minus j, time is t square. So if I will simplify this here, I can write here hence h equal to ut minus half gt square here, is it? This is the second equation. In this way, second equation will be used because in questions we have to write all these equations, then only we can solve the question. Okay. Now after that, if I talk about here the next one, third one. So third equation, v square equal to u square plus 2s. So here also I am going to use from A to B. Okay. So now what will happen that here, see here, anyhow velocity v, even if positive also, plus v square. I am just telling with the very basic, plus u square. Now see, velocities are all positive, plus 2 acceleration a minus g, and this s, how much here? Plus h. No, very basic, very basic, very basic. That means what will happen that here, see here, v square equal to u square minus 2gh. Basics should be clear regarding the sign convention, then only we can solve the question in a very easy mannered way, no, simple way. Okay, great. Now let's see here that situation again we are going to analyze, but from point A to C. No? As of now we analyze from A to B, now we will analyze from A to C. So see here, note, time taken by the particle to reach maximum height h is called time of ascent, Ta, as I have told you. At maximum height, velocity of the particle is 0, and as I have written also, Vc how much is here? 0. See, Vc. See, I have written here Vc is 0, now maximum height here. Okay. So now I am going to use these equations of motion from point A to C. A is initial point, C is final point here. Okay. See, again I am telling that here. This is A, this is C. From here to here, I am going to use it. Okay, great. So now students see here, A to C. Okay. So final velocity, what will happen at here? Final velocity 0, initial velocity u, acceleration minus g. Time taken, time of ascent. That means I can write here, very, very important, time of ascent is given by u by g. Time of ascent is given by how much here? U by g. Remember the formula directly. Okay. After that, remember that here, second thing, again if I use the equation from A to C. So A to C in a diagram you can see the height is the h, plus h or minus h, plus h. Okay. So see here, plus h equal to u Ta plus half a, how much here? Minus g into Ta square. Okay. So when you will simplify this, anyhow simplified only, so it will become here h equal to uta minus half g Ta square. Okay. Even Ta value you can put from here to here. No? This Ta value you can put from here to here, and you can get one desired equation that we can get by the third equation of motion also. How can we get by the third equation of motion also? See here, this how we are going to do here. See, again if I am going to use this equation from A to C. So what this will become here? See, v square, that means here 0 square, initial velocity at point A, u square plus 2 minus g, and height how much here? Plus h. Is it? That is the thing. So from here, if you will simplify this, you can write here 2gh equal to u square. What is coming here? 2gh equal to u square. Can you see very well? Here minus h this. That means we can write here h how much here? H is given by u square by 2g. No? H equal to how much here? U square by 2g, that is the maximum height. So students, make sure that here this one, and this one, no? Time of ascent and maximum height, sometimes we can use directly even. Okay. So see here, in how much beautiful way we have seen first from A to B, then we are seeing from A to C, and we have got some desired formula. Now after that, case 2 is coming, and in case 2, what we are going to see? Downward motion. Which motion here? You can see very well, the downward motion in absence of air. Okay. So remember that here, let's take for example here. Again, I am going to take some point here there. In a symmetrical way, I will take the point. Okay, so that there should not be confusion. Here I have taken point C, and let's take here I have taken point B, and let's take here I have taken point A, so that the point should not be confused. Okay, so anyhow, if we talk about the velocity, so I am considering that as of now, let's take the object is going to drop from the stationary object, or we can tell particle is going to drop from the stationary object like a building, tower and all that. Okay, so in this situation, remember that here what will happen that here, if I write here the velocities, let's take here velocity Vc, here velocity Vb, and here velocity is Va. Here velocity how much here? Here velocity is Va, is it? So remember that here when the object is going to be when particle is going to be dropped from the object here, because here two things are there now, so instead of object word I will use the particle. Now let's take this is the particle and going to drop from the building. Okay, so when the particle is going to drop from the building, the particle will get the velocity of the object. Okay, so if it is going to drop from the building, so called object, then what will happen? The velocity will be 0. Okay, and let's take what is happening that here when it will reach at point B. Let's take at this point the velocity how much here? Vb. Okay, and here at point A velocity how much here? Va. Velocity will increase. Why velocity will increase? Because velocity and acceleration both will be in a which direction? Downward direction. Okay, after that if I talk about here the time and all. Okay, so let me talk about the time. So let's take here at point C the time, let's take Tc equal to 0. At point B, let's take a time Tb is equal to T, and at point A, let's take a time Ta. Now, time taken to reach the ground when we drop, that is called the time of descent. Okay, and we can write here T equal to Td. Is it? Now after that, if we talk about this heights and all, so let's take here this height. This height how much here? This height is small h, and later I will write here this height will be capital H here. Okay. So this height how much here is small h, this height how much here? Capital H. And the sign convention, what I have told you, which kind of sign convention I am going to follow, you can see all the arrows are mostly downward direction. So by default always downward plus upward minus. This sign convention I will use here. And if I talk about here the gravity will act in which direction? The gravity will act in downward direction, is it? That means here A will be how much here? Downward positive, so A will be plus G, is it? So this diagram is very, very important, then only we can write the equations. Okay, so see here the first equation I am just going to write here. V equal to U plus AT. First, in a very basic way, I am going to use from B to A. Where to where? B to A, so that we should get some initial velocity and we should get some final velocity also. Okay, so if I will use from B to A, where to where? B to A. So remember that here B is the initial velocity, A is the final velocity. So what can I write here? See this VA is equal to UA. Acceleration how much here? Plus G, and time is T. Okay, so we can write here directly VA equal to UA plus GT. Understand the basics kindly. Basics are important. Second one, again, if I use from B to A, then what will happen that here? Again, B to A, displacement how much here? See, this is H, this is capital H. So B to A how much here? Even I can write here H minus H, is it? So remember that here I can write here H minus H, positive or negative? Downward positive. So plus H minus H is equal to, I can write here, see, initial VB into T, correct? T. One thing may happen. Why happening? Because here B to A means here TB equal to T, here TD equal to TA equal to TD. That means time taken. It will be here T, here TD. That means time taken will be TD minus TA. Okay, I will just make it here. See here. That time taken will be TD minus T, because here this time taken I am talking about here, this time interval, it will be TD minus T. How much time interval it will be? TD minus T here. Okay, so only I have written here the TD minus T, is it? I am saying in a very standard way. Okay, now after that here VB into, it will become here, see, TD minus T plus half, is it? And A how much here? A will be anyhow plus G, and here again we can write here TD minus T whole square here, is it? This is also equation, is it? See here. Now after that here students, if we talk about here this third equation, so third equation again I am going to use from B to A here, is it? So what will happen that here? B to A means, kindly see here velocity how much here? As I can tell VA, so I can tell you, see, VA square plus VA square, and here velocity how much? Initial velocity VB square plus 2 acceleration plus G, and displacement how much here? Again I am telling that here, this one this one. How much here? We can write here h minus h. Is it? So even you can write here h minus h here. Is it? So remember this basics also. No? This basics. Main thing is that you should learn how to use the equations and all that. Is it? Great. Now students, after that, what we are going to do here? As I have told you under the note, let's see here, under the note what is given. See, if the particle is dropped from a stationary object, as I have told you, some building, tower and all that, then its velocity will be 0 and time taken by the particle to reach ground is called time of descent. Now, so you can see very well. Now I am going to use equation of motion. Why all these things are coming? Because I am following one kind of symmetry that will be useful later. From there question used to come a lot. Okay. So now I am going to take point from C to A, and VC will be how much? That means now this will be my initial velocity and it will be how much here? 0. Okay. So C to A. So see here. Now I am going to use from C to A. Okay. So final velocity how much here? C to A means at point A velocity is VA. Initial velocity at point C 0 plus this one here plus g, and time taken how much here? Td. Is it? So we can write here when the object is going to hit the ground, it is going to be g into td. Remember that here, very important. Put the star sign, directly we can use g into td. Is it? Is it? Yes. Now after that, similarly, if I use from C to A, so again C to A means what much? How much here is there? C to A means you can see capital H is there. Is it? So we can write here C capital H, anyhow downward positive means this plus H only. So plus H equal to, we can write here C 0 into time taken how much here? Td plus half. It will come here plus g into td square. Okay. So from here what we are getting here? We can write here H equal to half g td square. This formula very important. Even I can write one more formula, that is given by td equal to root 2h by g. Now, and this is definitely very important formula. Is it? Both the formulas are important. Kindly remember that here. That's why I'm putting the star sign. Similarly, if we talk about here this one here, let's take again. If I use from C to A, and this here final velocity how much here? We can see here VA square is equal to initial velocity how much here? 0, because C to A plus 2 here how much here? Plus g h. Is it? So here also if you write here the velocity at point A is given by what here? See here students here, root 2gh. See, again we have got one more important formula. So in downward motion, multiple formulas we are getting it. Is it students? So I hope so all these basics and all you are understanding very well. Okay, and this diagram, especially the sign conventions and all that, very important. Now whatever way I am using the sign convention. Okay, now you will come to understand why I have used that symmetries and all that. Now, but like point A, B, C, then C, B, A. Now, so see here you can see the topic is what? The topic is C, symmetry of motion under gravity in absence of air. And here you will see that TA equal to TD. How can I tell that? See here, students. See. So now I'm going to take here the points. As I have told you, first the object is going upward. So let's take here this is point A. Now, and let's take here, for example, let's take here, I have taken this point B, okay, and let's take here, this I have taken point C, no, and let's take here, I have taken one point D, is it? And then, when in this situation, object is going upward, that means here what will happen that here velocity U, no, and when it will reach at the highest point, velocity at point D will be how much here? 0. And here what is this? This is the velocity at point A. Is it? So time taken from A to D is called what? Time of ascent. Now, so if I write here the time, let's take here what will come here? T equal to G. T equal to 0. Here what we can tell here students here? Here I can write here TD equal to time of ascent. Is it? Now after that, remember that here whenever the particle is going upward, it will go up and it will come down following the same path, same straight line, going up then going down. But if you draw both the diagrams in the same line, it will become very complex. Even we cannot identify it properly. So what we'll do here, for that purpose we used to draw like this here. We used to represent like this. Okay. Now here what will happen that here again we can give the same points now. Symmetry. This is point D. This is point C, this is point B, and this is point A. Okay, and after that here, as you know very well, if we talk about here the velocity, is it? So velocity, what is this? At point D, what is the velocity? You know, velocity at point D is 0 anyhow, And remember that in absence of air, when the object is going to hit the ground, it will hit the ground with the same speed. Direction may be opposite, velocity may be different, because here direction upward, here direction downward, velocity is different because of the direction, but speed is same. So what will happen that here also it will be Va equal to U. Okay, even if you see from the in absence of air, there is the no energy dissipation and all that. So with whatever energy we will throw the particle upward, with the same energy it will hit downward. That's why from kinetic energy point of view also you can see very well, if here energy, kinetic energy half mu square, so here also half mu square, because there is no air resistance, no energy dissipation, because air resistance just work like a friction in a air drag, air resistance, is it? So I think so all these things are clear. And if I talk about the time and all that, okay, so see here students, see here we can tell here the time, what is this anyhow, the time we can tell here, see now I'm using the TD dash, and here what is this anyhow, time of ascent is here. And now when we will come here, now when the particle will come downward, here it is going upward and here it is coming downward, and that time what will happen that here to here time of ascent, here to here time of descent. That means we can write here even time of ascent plus time of descent, okay, or even this thing you can write capital T also, and that is called time of flight. Okay, great. Now students, if we talk about here, now so let me write here, if I write here the time of ascent means where to where, I am using it from A to D. So A to D if I am using, time of ascent, you know how much here velocity is U. Now, so you know the formula, T equal to U by G. Is it how much here? T equal to U by G. Similarly, if I go from D to A, where to where? D to A. Now, basics are not going to change. D to A. So here what will happen that here, this time of descent, okay, I will use the small d, time of descent. This is also given by how much here? U by G. Why U by G here? See, here maybe initial velocity is 0, but final velocity here how much here? U. Okay, even you use any sign convention, answer will come same only. Now, and if I talk about here, one more thing, time of flight. So time of flight how much here? Time of ascent plus time of descent. So we can tell here U by G, this one, U by G, this one. So time of flight will be how much here? 2U by G. Time of flight how much here? Remember that here? 2U by G. Or even if I use here one more formula, so one more formula point of view, we can tell like this here, time of ascent is equal to time of descent, U by G, and it will become here half of the time of flight. Now this formula is also important, is it? So I think so up to this is very, very clear. And anyhow, by default, the gravity is acting in downward direction, that's not a problem. Now we are learning the some basics and all, is it? Now remember that here, if we talk about here upward motion, this is the upward, this is the upward and this is the downward. Now both the things we have to analyze together, is it? Then only we can solve the questions and all that, is it? So remember that here students, what will happen that when the object is going upward, you can see velocity is upward, gravity is downward. So you see this arrow and this arrow, both in which direction? Opposite direction. That means what will happen students in this situation? Velocity will decrease. That means if I talk about here, let's take this is 0 to 1, 1 to 2, 2 to 3. So what will happen that in each and every second, the displacement will keep on decrease. Why? Because velocities keep on decreasing, G and V in which direction? Opposite direction. So here even we can use the Galileo's law of odd numbers also. Just think students, how can we use the Galileo's law of odd numbers? Is it? So you can see very well here, Galileo's law of odd numbers tell that here, if in case initial velocity is 0 and initial velocity is the U, and final velocity is 0. So in this situation, we can use the Galileo's law of odd numbers. According to the Galileo's law of odd numbers, what will happen that here? Odd numbers will be involved here. Now, so let's take here, I can tell you this is the 5x, now odd numbers. What is this? Let's take here, this is 3x. This will happen, definitely it will happen, is it? That's why I'm teaching you this basics. And this is the x. So when the object is going upward, what will happen there? The velocities keep on decreasing. So in first second, it will travel some more distance. Let's take 5x. Then in next second, 3x. Then in next second, x. Is it? So this is the situation. After that, what will happen there? When the object will fall. So you know, in that situation, what will happen there here? Just let me draw here like this here. I will draw like this here so that we can correlate it. Is it? So when the object will fall, you know what will happen there here? If I draw here like this. Now, so when the object will fall, what will happen that here? Here speed is 0, is it? Now when it will fall, speed will keep on increase. So when the speed will keep on increase, the distance traveled in each and every second, it will also keep on increase. So we can tell here, let's take this is x. Now, this is how much here? 3x, and this is how much here? 5x. Is it? So you can see very well how much symmetricity is there. Here velocity is decreasing, that's why 5x, 3x, x. Here velocity is increasing, that's why x, 3x, 5x. Is it? Now students, after that, from where the question used to come. So what will happen that here? I can tell very well. Now, so we can tell very well AB is equal to BA. What we can tell? AB is equal to BA. Is it? And if I take here the some sign and all, no? Sign. Sign means what? We can tell here, let's tell, if I do the just numbers here, let's take t equal to 0 time, t equal to 1, t equal to 2, and here t equal to 3. Here again, t equal to 3, see here, t equal to 4, t equal to 5, t equal to 6. Now, so what is happening that here? See symmetricity. Time of ascent, 3 seconds. Time of descent also 3 seconds, is it? So here we can tell, just for the example we have taken this, time of ascent is 3, time of descent is 3, and total time of flight how much here? 6 seconds, is it? So what will happen that here, as AB equal to BA, AB means where to where? 0 to 1. That means, remember that here, displacement traveled in first second of motion. Remember that, first second, second second, third second, fourth second, fifth second, sixth second. Okay, so displacement in first second will be equal to displacement in sixth second. Remember that, very very important. Okay, question will be there. If we talk about the next one here, you can see very well, BC is equal to CB. What is given here, students? BC equal to CB. This will only happen in the absence of air only. Okay, so BC means what? Displacement in second. That means H2. Displacement in second will be equal to displacement in fifth second, is it? So H2 equal to S5. H2 equal to how much here, students? S5. Similarly, you can see CD equal to DC, is it? So what can I write here? See, CD is equal to DC. What is the CD? First second, second second, third second. That means displacement in third second will be equal to displacement in fourth second. Even here I have taken time of flight 6, even you can take 8, 9, 10, no problem, all these things will be applicable. And here the main point of important point is that you can see very well this thing. This is called the last second, last second, that's here 2 to 3, last second of ascent. And what is this 3 to 4? This is the first second of a descent. So remember that here, as you can see very well, S3 is equal to S4. That means displacement in a last second of ascent is equal to displacement in a first second of descent. Is it? Can you see very well? Can you see very well? Is it? So I can write here, see the students. If I write here, I am going to write it, very important point here. See, I am writing here, see, displacement, question used to come from here, displacement in last second of ascent, displacement in last second of ascent, as it is S3 is equal to, what is this here, students? Displacement in first second of descent, first second of a descent. And what is this here? That will was S4 here, even you can see also. Now see, S3 equal to S4. Okay, and you can see very well here initial velocity how much here? See very well, initial velocity how much here? 0. Okay, and here t equal to 3 to t equal to 4, how much time is there? 1 second. Okay, so even I can use the equation of motion also. Where to where I can use the equation of motion? I can use the equation of motion from D to C. Okay, so if I use the equation of motion from D to C, okay, D to C I am using, yes here, D to C I am using. So you know that here ut plus half at square, again I am writing, see, ut plus half at square, ut plus half at square, is it? So remember that here, this thing anyhow, up to this is clear, this is the thing, this is done, okay, this is done. But now I am calculating displacement in last second of ascent or displacement in a first second of descent. So if I use the formula ut plus half at square from D to C. So at point D, what is the initial velocity? 0 into t. T is how much here? 1 second. 1 second, let's see here. Last second. That means t equal to where? Can you see here? Last second. That means t equal to where? T equal to 2 to t equal to 3. Is it? So last second here. So half. A value how much here? Remember that here 9.8, and time how much here? 1 square. Okay, even t also, this also you can put 1. So it will come here 9.8 by 2, and answer will come 4.9 meter. Very, very important. Very, very important. Displacement in last second of ascent is equal to displacement in first second of distance. And here how much here? 4.9 meter. Even time of flight I have taken 6 seconds, 8 seconds, 10 seconds, 12 seconds, 50 seconds, does not matter. Displacement in last second of ascent will be how much here? 4.9 meter. This we can't calculate it very easily, is it? Why we can't calculate it very easily? Because then we have to calculate the velocity here, is it? But instead of calculating CD, we are calculating what? We are calculating the DC, is it? That's why displacement in last second of ascent, 4.9 meter. How we got very easily? By calculating displacement in first second of descent. Is it, students? So kindly remember that this pointer very, very well. Directly question used to come. Okay. Now students, after that, time of ascent and descent in presence of air. And here you are going to see that the time of ascent will be less than time of descent. Why it will happen that here? Kindly see very well. So again, let's see here, students, here. I am taking the object from point A with velocity u. With velocity u. Okay. It will go up. Now it will go up. Let's take here at somewhere point C. Now let's take at somewhere point C. Its velocity will be how much here? Let's take velocity will be 0. And here at point A, velocity how much here? U. Is it? Now after that, what will happen at here? If I talk about the time taken. So remember that here, student. This time taken t equal to 0. And here time taken how much here? Time of ascent t equal to TA. Is it? Now again, after reaching there, on the same path it will come down, but for the simplicity purpose we are doing. Now what will happen that here? From here again, from point C, again it will start to fall and it will hit the ground. So what will happen that here, students? Remember that here at point C, anyhow velocity is 0. But remember that in presence of air resistance, speed will decrease. Now because see, let's take for example, you throw with the kinetic energy 50 joule. Some energy has lost here because of air resistance. So do you think here the energy will be 50 joule? No, here the energy will be less than 50 joule. So because of that, what will happen that here the speed will be lesser than the speed u. Okay, so I can write here this is the speed u dash, and this will be how much here? Less than u. Remember that now by seeing the kinetic energy perspective very easily. Okay, so let's take here again, I'm taking that here, let's take here, I'm taking that here, let's take time is tc equal to 0, and let's take here again the time is here ta. Here ta, I have taken here ta dash or tc dash, and here let's take time how much here? This is descent, this is ascent, this is what? Descent here. Is it? So remember that here when the object will go up, when the object is going up, so remember that here what will happen that here? Anyhow, gravity is downward and upward means air resistance is also downward here. Okay, and I am considering, let's take here, it is coming here A equal to G plus R here. Now, because both in which direction? Downward direction, is it? And I am taking, let's take here, let's take, for example, downward positive. Now, so you know what is the formula is there, students? Remember that here, see, time of ascent is given by u by g, or we can write it in a very basic way, u by a. So here what will happen that here, remember that here this time of ascent is given by u by g plus r. What is r? R is the air resistance, both in which direction? Downward direction. Okay, similarly sometimes they used to ask, if I talk about here the time of descent, so time of descent will be what here? From here to here. So here what will happen that here, remember that here the gravity is downward, object is going down, that means air resistance in which direction? Upward direction. Remember that here it will always oppose, is it? So here you can see very well G positive, R negative. So in this situation A will be G minus R. What will be A? A will be, students, G minus R. So if I write here time of descent, you can write here u dash. Even sometimes in a books and all you will see here also they will write u, here also they will write u, to keep the thing simple. But I have told you the factual things, is it? So here what will happen that here u dash by A. So it will become here, kindly see here, u dash by, we can write here G minus R. What is there, students? We can write here G minus R here, kindly see here. Okay, so here you can see, students, T equal to u by G plus R, T is equal to u dash by G minus R. Okay, and if I am considering, let's take u dash is equal to u approximately. So what can you tell here, students? Here the denominator is the small, no? So this will be more. Here denominator is the more, so TA will be less. So we can write here hence TA will be less than TD when air resistance present. Can you see very well? Can you see? Is it, students? So I hope so. This video of motion under gravity, we have discussed all the concepts and all that is very clear to you, especially the symmetry in absence of air, important for the NEET and J exam. So students, I hope so. You are studying very well. Keep studying, keep doing.